Hey, it's Paul Browning here. I wanted to go through a Cram guide for the CCNA exam. I'm going to split it into two because some of you will be taking the two exam route. So if you're doing the one exam, the CCNA, just in one exam, then go through both Crams. If you're doing the CCENT first, which is the ICND1, and then the ICND2 next, then obviously you can do the two Crams. I'll just get rid of this. So the ultimate Cram guide, I'm going to pack in as much information as I can, but this is just the bare bones stuff because it's a Cram guide. This is version 1, the first version. I've done Cram guides over the years, but I'm going to make this the official first version. And then whenever I update, I will let you know. I'll tell you how to find out. One of the ways, obviously, is just hit the subscribe button under this video to the right, and anytime I do a new upload, you should be notified. I think there's a little bell button that you can actually get notifications for when I do it. If you want to be emailed, I'm going to actually make these slides available soon. Not quite yet because I just need to get some changes done. But you can go to howtonetwork.com, and then if you go to free training, there's various free videos and other goodies there. And what that will do is if you get an email from me when you put in your email address, if you click to confirm that I can send you emails, then whenever I update this Cram guide, I'll send you a copy. I also send other IT tips and stuff. These are a few. I think I've got about 20 on sale at the moment. These are some of my books on Amazon.com. CCNA, CCNP, IP subnetting, and mainly Cisco stuff, but I've got some CompTIA stuff also. I used to work for Cisco TAC. I was in the police actually for several years in the UK. Then I went into IT and started teaching courses in 2002. As you can see, I've written quite a few books now and co-written some. I started knowing nothing, so if you're a beginner, then you're in good hands because we've all been there. Just a quick introduction to my websites in case you're looking to get certified or trained. howtonetwork.com, 101labs.net, which is learn by doing, as it says. It's all practicals. There's no theory on that site. And then my in60days.com. At the moment that's got CCNA, but I'll be adding more stuff to it. So let's get into it. You need to know everything that's on this video, and when I get these slides all checked, I'll be sending out these slides. If you go to the page I showed you earlier, so you need to know all of this stuff. It's not a replacement for you studying, obviously. It's just a Cram. If you want to pass, you need 3 things, and I've done other videos on this. Number 1, you must do labs around, say, roughly 50% of your time doing hands-on labs. Roughly 40% over here doing theory. You do theory, then you read the labs, you do the lab, and then read some theory on that particular subject, for example, access list. And then you spend around 10% of your time doing practice exams. As I mentioned earlier, I've got some websites. You can have a look at those. They're packed full of loads of practice exams. So stop the video as and when you need to. You can take notes, but soon, I'm not sure how soon, but as soon as possible, I'll get these slides available for you to view as a PDF, so you can look at them wherever you are. So I'll jump straight into it. Topologies. Now these are the names of the topologies. So these are the kind of choices you have. Physical means what we see, and this is a pen that goes on a tablet. So I'm sorry if my writing is awful. What we see. Logical is what the network sees. So you could walk into your server room. You won't see this anymore, but unfortunately you could still be asked about it. You could walk into your server room and see a switch that looks like this over here, a token ring switch, and it would look like it's a star topology, and a star topology has a device connected in this kind of fashion with wires coming out. But really inside, I'll just lower the volume slightly, inside here is a ring, and the traffic passes around this ring, and if at any point this ring gets severed, if something's broken, or if one of these devices goes down, then the entire network goes down, which is one of the reasons why we don't use token ring. So that's the difference. You need to know all of these. I'll move on. Firewalls, you would be asked, this is all in the syllabus, so stuff's been added and removed and changed. You basically need to know the difference between stateful and stateless firewalls. Please pause the video so you can look at it for yourself. You may do some further reading on this as to where in the network these devices are placed, and you could be asked about something like would they be placed in line or not. So hopefully you've got a good quality study guide. Will give you some more information. Wireless was in the exam. It left for a while actually, and now it's back. And this will be because Cisco customers said please add it, because our engineers don't seem to understand it and we want them to. So there's some information in there. Check the syllabus. Obviously I'm concentrating on what you're going to be asked, not teaching you how all this stuff works. That's obviously for a course. But the tricky exam question is it will use carrier sense multiple access with collision avoidance, not collision detection, not this CSNA with CD. So just be careful if they try and catch you out in the exam. You've got a centralized administration hub called your WLC, wireless LAN controller. If you use Packet Tracer for any labs, you can play with that actually. It's good fun. With wireless LAN controllers, the access points, so these are your devices that you're using phones or whatever, they will connect to your access points, and then your access points will be wired or wireless to the wireless LAN controller. Again, hopefully this is covered in your study guide, whatever you're using, or your videos. Another typical exam question, multiple APs servicing the same service set ID, which will be the name that you can see when you search for wireless networks. This is referred to as an extended service set. A single access point is referred to as a basic service set. I'm basically, if you haven't already noticed, targeting typical exam questions throughout this video. Now this has been the bane of everyone's life for, well, yeah, decades now, I'd say, the OSI TCP model. So this, it's not a physical thing, it's a logical way of us viewing the network. So in our head we can, and I'll draw the worst picture of somebody's head, when we're looking at troubleshooting a network problem, in our head we can think, hang on, I've had this information and that's telling me that this is where the problem could be, this is where I'll start troubleshooting. Troubleshooting, you can go bottom down depending on what information you're given, or top up. So if the whole network's working and it's something to do with people not sending or receiving email, then you could possibly start top down, looking at the email server. If the services are working correctly, you can work your way down and see if there's a correct routing information stored on this particular server. If it is correct, then you can go down to the next layer and say, well, hang on, what's going on with the layer 2 interface? Is there a VLAN issue, configuration? And then finally, is the cable faulty? And this is basically going to save you time and effort. Now, each of these layers, as you can see, we start with 7. Don't make the mistake of saying we start at layer 1. It's a top-down layer. So 7 down to 1. Application, presentation, session, transport, network, data, and physical. And as you can see, each one's got its own role, which you can learn if you stop the video. Data, you need to know what data is referred to at these layers, and it's all data here, and then each layer has its own specific terms just down here, nomenclature I was thinking of the word. And we've got the TCP. We need to know how the TCP model, and again it's just another logical model, maps to this particular model. So OSI model, TCP updated. Depending on how old your Cisco book is, it will be 4-layer, but as you can see, this is a 5-layer. 1, 2, 3, 4, 5. Books contradict each other, unfortunately, and I've had a few angry students email me saying what the hell is going on, or your book's wrong. It just depends on which model you're looking at. Obviously, we're going to stick to how Cisco interpret this model. The way to remember the layers and the data formats is all people seem to need data processing. So that's your application presentation session down to physical, and your don't some people fry bacon is your data terminology. So data, segment, packet, frame and bit. This is how we remember it for the exam. Common port numbers, you need to know all. You need to know, have a look at all of these. This is obviously your FTP. Which ones use TCP, which ones use UDP, and which ones will use both and under which circumstances. So DNS obviously uses UDP normally. There are a couple of instances where it uses TCP. So read through your study guide and just note in case they try and catch you out in the exam. You need to know all of these port numbers. Obviously there's thousands of others, but these are the common ones you'll need to know about. Here's some more information, and again it's just a case of you pausing the video, but you could just get sneaky questions like they give you a packet from a Wireshark capture or something like that, and inside it will just give you a little bit of information. It'll say something like, oh, the protocol number 17. Well, if you've learned this, then you'll know it's a UDP packet, for example. Or down here it could be a capture and it would say ports, a destination port is 53. What would that be? And you'll immediately think, oh yeah, that's DNS. You need to be able to configure DHCP. It's the same for the switch or the router. You start off, obviously config T, you give it the name. They will try and catch you out and they will miss off a part of the command. For example, some commands start with IP, some you don't put IP in. This could be a throwback from when we supported older protocols, for example, IP, XSPX, Apple Talk, etc. Anyway, so the name is obviously whatever you choose it to be, and then you'll configure the network. So this is there's different ways of doing this. So again, when you come to configure this, get to this part and hit the question mark, because with some configuration services such as NAT, there's more than one way of doing it. You could do a slash. I'm not saying you can with this, I'd have to check on my router. Or you could net mask is another one. So go this far, then hit the question mark and you'll see what your options are. This is optional, your DNS server. Your domain name is optional. Your default router, I think that's optional, you don't need to put it in. Now lease will be value 1, value 2 and then value 3. Get to this part of the configuration and you can see the output, by the way, is important to know. Lease and then hit the question mark, put something in here, space, question mark, put the next value in, and so just so you're clear in your head what these values are. You type exit here. This is a gotcha in the exam. They will try and catch you out by saying put this command in and they will show you this output. This command will obviously work at this output, but this is not the correct way, but this is how you would actually put it in if you were doing your configurations. So Cisco routers recognize what you're trying to do and will drop you back to the next lowest mode. Alright, client as well as server is included in the exam. If you want your router, for example, to be a DHCP client, you just go to whatever the interface is, IP address, and instead of putting the numbers in and the mask, whatever it may be, you just say, oh, we'll use DHCP, and then it will broadcast for the DHCP information. After you've been allocated the IP address, you'll go show IP interface brief. There's other ways of doing it. Show IP interface for fast Ethernet 0/0, and it will say under the method column allocated by DHCP. That's obviously if you've configured it correctly. Cisco networking model is now in the exam. It was in, then it was out, now it's back in. This is actually far more CCDA, so the Design Associates exam, not the Network Associate. This is probably one of the best exams you can take. It's one of my favourites. So this is how they separate the network devices and functions into 3 different layers. Now if you're working in a tiny little office, it's just going to be silly. So instead of having 3 layers, the core, distribution and access, you have what's known as a collapsed core. So this has the core and distribution all put into this layer here, and then you've got you still have to have the access layer, and the access layers for your PCs down here and all of your hosts. There are some rules you need to know for the Cisco networking model. What the core layer is designed to do, which is switch traffic as quickly as possible. The thing to remember here is you're not going to do any packet manipulation. So you're not going to be doing any quality of service or ACLs. Do not. You will slow your traffic down. You'll learn more in the CCDA if you do it. Distribution layer, the center. This is where you choose which of your switches would be your route for your spanning tree, which you'll I think that's in the ICND2. I'll know when I come to do the slides. And then finally access layer, where your segmentation occurs. Router modes, don't overlook this really basic stuff, because they'll still ask you what do these prompts mean. What mode are you in? Are you in privileged, user exec here, privileged here? You're in global config. This is ROM mode is normally for a password recovery. It normally means something's gone wrong unless you on purpose, as the network administrator, have gone into this mode to recover it. Often when you buy a second-hand router or switch, which is a bit different actually, or you get some equipment off eBay and somebody's left a password on. Setup mode is when you boot up the router and it says, do you want to enter initial configuration mode? And we always type no, because you get asked a series of questions and then the router doesn't work anyway. This is a legacy. I only mention it because you might be asked. You probably wouldn't be in RX boot mode for anything, but just remember the prompt. Keyboard shortcuts, again, this is the stuff that sounds boring and you'll skip over when you see it in the books. I always include it in my books because it makes you a better engineer and you could get asked questions. So boring. You've got to learn what control and a key does, and you've got to learn what the various escape and the keys works. And you could get asked the question, you could have one answer or you could have 3, 4 or 5 possible answers. And to recall the previous command, one of your answers would be control and P, and your second answer would be just hit the up arrow. So this is the kind of thing where you get such easy marks, and it's such a shame when you can't get these easy marks. Obviously when you start typing out a command, like if you did SHA and hit tab, it would probably add the rest for you, and it does it with some other commands as well. Cabling, this is boring stuff but bread and butter, and you look like such an idiot at work, or if you have a technical interview and you don't know how to answer this question. One of the main things is like to like is almost always a crossover. So switch to switch, crossover, router to router. You don't have a switch if you're connecting a router to a router, so this would be a crossover cable, and the same here. So just learn these and you'll get an easy mark. This is your sort of crammer guide for cabling. If it's a crossover, pin number 1 always goes to 3. Pin number 2 always goes to 6. You could get asked this, or you could have a figure such as this, and it will say in the exam, what's this cable? And if you've learned this, then easy peasy. Straight cable we just use for normal host to switch. Rollover, it's called a console cable. Console. I'm telling you this because you'll be at work and somebody will say something, and if you don't know what it is, you look silly. Console, flat, rollover. And again, if you're just working in a team, it's your kind of first job in networking, you don't want to look silly for these silly things and have to start running off and Googling it. So console flat rollover, everything's reversed. This goes here, number 2 goes to number 2 goes to here, so that the cable basically just gets crossed in the middle, or the wires get crossed. So you'll see your orange, say it's blue here, then the blue cable will be at the other end here. Interface speeds and duplex. If you do the show interface, and normally it will be on a LAN interface, you'll see some interesting information such as your MAC address, IP address if you've got one configured. The other information you're looking for is this working at half duplex, which you'd probably never see nowadays, but it's still in the exam. Is it working at 10 meg, 100 meg, 1 gig, etc. Half duplex is one way at a time, like a walkie-talkie. Full duplex is 2 ways at the same time. If you do need to make a change, you'll go into the interface. All you need to do is hit duplex space question mark, and you will see your options, and then obviously you'll enter the one that you want. If you want to change your speed, then it will be the same thing, interface whatever, and then speed space question mark, and you will have a choice depending on your interface type. You can connect to a router several ways. The console cable, we've already talked about, the flat rollover cable. Normally if it's a disaster or you need to do an initial configuration. Aux port, you generally don't get these now, but you can have them as a module for modem connection out of band. If you've ever used the telnet command, it's changed now actually, it's like 0 to 15 I think. If you're using GNS3, you're going to need to hit the line VTY0 space question mark, because you've got hundreds, and if you don't do this right you get a lot of errors. TFTP, Trivial File Transfer Protocol, very rarely used now, but it sends small files. A network management station can be used to remotely manage your equipment and your devices. Now excuse me while I have a quick sip of coffee, because this is going to be a long session. Cisco Discovery Protocol, really handy protocol that you need to know really well, but it would only take you 10 minutes. This is a Cisco proprietary, the clue's in the name, so it works on Cisco equipment. It's a layer 2 protocol. It gets information about your nearby connected devices as long as the interface is up. Now this could be asked in the security, like security hardening your devices for Cisco switches, routers, etc. Disable it on the entire device is no CDP run. If you want to turn it off on the interface, and you would normally disable it, so on your LAN side here, if you've got a switch for example, you would have it probably enabled here. On your internet side you would probably have it disabled, but you'll decide your own policy, or you'll be told about it. Show CDP neighbor, this will give you X, Y, Z. You type this command on a router to see for yourself. If you add the detail command you will get X, Y, Z, but you will also get A, B, C. So check for yourself, because you need to know what you get just for this command, and when you add the detail you get more information about the model, the iOS, IP address, etc, etc. And again, it's an easy question. Use it for troubleshooting also. LLDP is a new addition to the syllabus. It's open standard, so this is an important thing to note. IEEE standard 802.1ab. Very similar. The difference is this is disabled by default. CDP is enabled. So please remember, config T, the command to enable it is LLDP run, and that will enable it globally. You can disable per interface or enable it, so you could just go to your interface and you could say LLDP transmit, LLDP receive, and then to turn it off you would obviously know in front of these. Please do try these commands, by the way. Your LAN switch, it learns addresses. You must know this command because it's a common exam favourite. Now just be careful, because older versions of code had show MAC address but without the dash. So go onto your 2960 switch or on Packet Tracer, which is free, and go show MAC, and then hit a question mark right after the C, don't leave a gap, and then see what your options are. But this should be the current version with the 2 dashes. It filters and forwards frames, avoids switching loops. This uses the Spanning Tree Protocol, which is a big part of the syllabus now for ICND2. The other thing you need to be aware of is collision and broadcast domains, and you will have a diagram. It won't give you the answer like this diagram does, but this is identifying the broadcast domains. So important thing, which I'm sure you've learned, is switch routers by default do not forward broadcasts. So all broadcasts on this LAN here, for example, will stop. All switches will forward broadcasts because that's what they should be doing, but your router will not, because it would bring the entire internet down. The other thing is each port on a switch is a collision domain. So if you've got 10 devices plugged into this one switch, you will have 10 times collision domains. Bridge is the same as a switch. Switch is basically just a multi-port bridge. The other thing which they might put in is a hub. Hubs are dumb devices. They will forward all traffic, and they're in a huge collision domain here. So pause the video again and just confirm that in your own head. Transmitting frames, you need to know the 3 possible options for the typical layer 2 switches. The thing you need to know is this is the default. It's got the highest latency, which means it's the slowest because it copies the entire frame into a buffer, does a CRC check. But on the model currently tested in the exam, this is the default. Cut through is it reads only the destination address, so this is the lowest latency. This means it's the fastest. Fragment free basically just reads the first 64 bytes. The reason why it does this is you're most likely to have errors in the first 64 bytes. So you can configure this on your switch if you so wish, depending on what your network rules are for passing layer 2 traffic. The 2960 uses 802.1 encapsulation. Your other version on older switches, which I think is still supported, is interswitch link, which is for Cisco devices only. You won't be asked about this in the exam anymore. It's 802.1q. 802.1q, just some of the things you need to know about. It supports up to 4096 VLANs. You can do a show VLAN brief actually on your switch, and you can see more information about that. It uses an internal tagging mechanism. It modifies the original frame. Open standard. It doesn't tag the frames on the native VLAN. Please read up on that. The native VLAN is passes all information by default on the switch to switch. I think we'll talk about this later on. But you can see a tag is inserted into the data here. So this is your LAN. Your trunk link is here, and the tag, which has got your VLAN ID, for example VLAN 10. It gets to the other end of the trunk switch, is taken off, and then the data is passed over to the correct VLAN number. And here we go, the native VLAN. So the definition is it provides connectivity to old 802.3 ports that don't understand the VLAN tags, which is what we saw in the last diagram. By default, VLAN 1 is your native VLAN, and you can change it with... You must go into the interface, and it's switch port trunk, native VLAN, and then choose your VLAN number. For security, you would choose a high VLAN number that is not in use. So just bear that in mind, a high VLAN number and one that isn't being used. This is for security. Native VLAN must match on either side of a trunk link. So if you've got your switch here sending out on this port here, and if the native VLAN is 10 but on this side it's 2, you've got to start getting error messages thrown up, and the error message will specifically tell you what the problem is. Port security, no surprise that it protects your switch ports, and I'm going to have some more coffee, excuse me. You can permit or block static MAC addresses. Your 3 violation shutdowns are shutdown, protect, and restrict. There is a 4th, which is shutdown VLAN, but that's a CCNP topic, so don't worry about that. You can restrict an interface so only devices that are expected to be sending traffic through can be connected. Obviously, it's on layer 2 switches, it's identifying based on MAC addresses. You can define a maximum number of MAC addresses per port, check your documentation, or use the question mark on your switch to see how many. The important thing to know is with each of these 3 modes, what happens if there's a violation. The port is protected, which means unknown MACs are discarded. Shutdown mode, the port goes into error disabled and no traffic is passed. This has to be manually enabled, which is basically shut and no shut command. There's a recovery option also, error disable recovery cause, which hopefully is covered in your book. The other thing is you do need to know if a syslog message is generated. Classic exam question, so learn this. Protect mode, you don't have a syslog message. For shutdown and restrict, we do have a syslog message, so it will be in your login file, and it sends an SNMP trap. There's a violation counter, which I'll show you in a minute. They are incremented as well. So you can see the type of sneaky questions. You think you've learned this, and then you get the question in the exam and you realise you haven't. And just down here, as I said, you can see the security violation count. So far in this switch is 0. Show port security. Remember there's a dash, interface, whatever. So it's enabled. It's currently up. The violation mode is shut down, which is the default. Aging type absolute, you can read up on. It's allowing 1 MAC address by default. The last source MAC address is this. Don't think it's not using it's not using sticky MAC addressing, so if another device came through, that would be fine. Port security, I've said you can limit your MAC addresses. Sticky, this is another exam question. It basically learns the MAC address, so the first device that transmits through this switch port, it learns it, but it goes into the, you will see it in the running configuration. So try it for yourself when you do a lab. You could type show running configuration and then it will pop up under the interface, for example, fast Ethernet 0/1, and it's been added. If you reload the switch, it will be removed, the MAC address, and it will relearn a new one. You can do static or dynamic entry. I've already mentioned the violation modes. The other thing is this is a security feature. Shut down manually ports that aren't in use. All unused ports, just in case, are assigned to an unused VLAN, something that's got a high number. Configuring port security. These are your basic steps. You have to enable port security globally first. So you have to enable it first, and then you actually repeat the command, and then with the switches at the end. So you could change the violation. That's by default, so you wouldn't need to add that command if you just wanted it to be shut down. Maximum number, hit the question mark to see how many you could have. I've put 4 here. Switch port security MAC address, and then you will put a MAC address of whichever device is allowed through this interface. And then show port security is globally, or you can carry on typing the specific interface name. Onto VLANs, you logically divide your LAN up into virtual local area networks. It cuts down broadcast domains because it's acting as if it is a LAN. Good for security is one of the reasons you do it. Easy for you to administer the network. Your VLAN information goes over your trunk link. Configure a VLAN. We've got a simple configuration here. You would enter the number, so VLAN 2. You could actually then go name if you wanted to give it a name. A lot of people do. So hit enter here, type name, and then whatever. Admin. Then you would go to your interface, hard code it as an access, because usually it's dynamic, which means it could become a trunk or an access. Switch port access, what VLAN are you in? And then I've done the same to another interface. So it looks like I've gone to 1 and to 3 and said you're both in VLAN 2, and I created VLAN 2. If you miss this off, it's pretty clever actually. I can't find my, there it is. If you miss that off and go down here and say VLAN 2, it will say VLAN 2 doesn't exist, creating it, so it will do it for you. I'm not suggesting you try that in the exam, by the way. Types of port, you can see access ports on the bottom there connecting to your hosts. Trunk port will go to other switches or a non-edge device connected to this port. Just a quick configuration example. You have to obviously pass multiple LAN information, usually over a trunk link. So you could VLANs. So you could have VLANs 10 to 30 inclusive have to pass over. So we obviously have to have an encapsulation type over here. Now, like I said, ISL isn't in the exam anymore, but that was your option on higher model switches. It should be at least 100 meg. Just in case, and I've heard this in the exam, they will give you a list of what speeds you need. You can have a 10 meg link as a trunk. Try it for yourself if you don't believe me. Not recommended, obviously, but I'm basically giving you answers that you would tick in the exam, and you would obviously tick, yeah, that's obvious, yeah, that's obvious. You could miss that off, and then you don't get the mark for the exam, and it's such a shame if you just miss by a couple of points. It really is. Here's a sample configuration for your access and your trunk ports. I hardcode this interface to switch port mode trunk. You used to have to add the encapsulation type before you did that, but no longer. And here comes another sip of coffee. VTP, VLAN Trunking Protocol. So this makes your life easier as a network administrator. VTP is your friend, and it kind of works automatically with the facility for you to do some tweaking. So just learn the commands you can use. It carries VLAN update information between switches, if they've been added, removed, deleted, etc. All your devices must be in the same VTP domain, which they are by default. Your 3 modes are client, server, and transparent. You need to know what each one does and doesn't do, and the default. The default is server, but you could lose your job if you do if you make a mistake and add a new server into your VTP domain without first configuring it. So be careful. And there's your warning there. So here's some sample configurations. You can change the domain name. You will change the password. All switches must have the same password if they're going to pass VTP information. So do check. So just a sample configuration. I mentioned names before, VLAN 2, and I give it the name sales here. This is just for your administration. So when you issue the show VLAN brief command, you can see your VLAN names. Set in a trunk here, VTP mode, my various options, my VTP domain name, and then spanning tree port fast. I think that's actually covered in the ICND2. Some show commands you'll need to practice on your switch, so please, whenever you do a switching lab, practice these and learn all by heart. Dynamic Trunking Protocol basically tries to help you by negotiating the port to become a trunk. It's always on unless you manually turn off. Whether or not this is a security issue for you, you decide as the network administrator. Is it something you think is desirable behavior or not? I missed a gap here, sorry. Interface fast Ethernet 0/2. Switch port no negotiate turns off DTP. So you can see I tried the command on here, but first I had to issue the switch port. I should have had a gap again, I'm sorry. Switch port mode trunk and then switch port no negotiate. That will stop the dynamic negotiation of it becoming a trunk. Just learn these. I think I've got it on another slide as well. You need to know for the exam which configuration settings will enable a trunk forming. So in all of these scenarios, a trunk will form. In these scenarios, you do not get a trunk link between your two switches, which is here and here. So what are these scenarios? So pause the video and learn the DCP modes and if it's been statically configured as a trunk or not. Address types. Unicast is 1 to 1. So one device contacts another device, and this is obviously all going to be contained in the fields of the IP packet. Broadcast 1 to all, everyone. Obviously, if you've got a switch here, that will forward the broadcast to everywhere else. If you get to the router, it will stop at this interface. And then multicast is 1 to many, and it will be a subgroup of your network as it shows you here. You would join a multicast group, or you may configure a routing protocol such as ERGRP, which uses multicast address, and any router that's using ERGRP will listen out on certain IP addresses. You've got for IPv4, so this is IPv4, you've got your 5 classes of IP address. As network engineers, we'll only really be using these. Class D is your multicast. You do need to know what your leading bits are in binary so you can recognize it. I've never done this in the real world, but in the exam they will ask you these kind of questions. What are the number groupings for the first address in the first octet? You need to know these, and then you'll cover this when you do your subnetting and IP addressing. This is the subnetting cheat chart that I created several years ago, and this is what got me through multiple Cisco exams, and it's saved me in many technical interviews also. So your subnetting cheat chart, the top here, so this part here, all of this is for working out which subnet a host is in. If you get asked a question, this is the how many subnets and how many hosts. This is the design section of the chart. So all you do is start off with the number 1 and double it until you get to 128. So this is basically an octet, which hopefully you recognize. And then if you take this number 128 and then add 64, you get 192. If you add 32, you get 224. If you add 16, you get 240, all the way up to 255. So these are your possible subnet values. This is where these numbers will come from. Easy subnetting. If you don't know subnetting cold, I've got a best-selling book on Amazon, IP Subnetting from Zero to Guru, which I updated in 2019 actually. So it's got IPv6 in it and a load of other stuff. So easy subnetting for the exam, change the / number to a subnet mask, tick down and across the chart, count it up in increments till you get to the correct subnet. So you're sitting in the exam, 172.168.100.11. Which subnet is it in? If it's got 19 bits of 19 bits for the subnet mask. Well, to get to 19, the default for a class B, I'm sure you already know, is 16, which is 8 plus 8, and then we've got something else has happened here because we've added 3. So tick down 3 and tick 3 across the top, because the default for a class B network is 16. They've given us 19, so we obviously have added 3 to that. That's how I worked out that number. And you count up in increments of 32 until you get to the 100.11 subnet. So class B, and again I'm sure you know, this is fixed. The first 2 octets are fixed for class B. So let's have a look. We stole 3 bits, so our 16 bits are already catered for here earlier on. So we're now going into our 3rd octet here. And you can see we stole 3 bits. So it's 16, 17, 18. We've got 19 bits for our subnet, so we've ticked across 3. This tells us that our subnets are going up in increments of 32. If you wanted to write out your subnet mask, you would tick down 3. To see that you get your 255.255, which is 16 subnet bits. We took 3 bits here, which tells us that that's 240. So the next bit is we're looking for this class B network, and it's the host 100.11. And we know we're counting up in increments of 32. So 0 on the 3rd octet, 32, 64, 96, and we would carry on. but we're looking for host 100, and we're pretty sure that 100 comes after 96 and it's earlier than 128. So this is obviously it takes practice, but this is our quick way of doing it for the exam. To work out all your IP addresses, we'll go to the subnet that we're in. Your first one would be 96.0. We add a 1 as our first host, and we keep adding numbers 2, 3, 4, 5, 6, 7. Unfortunately, you've got quite a few. You've got a few thousand here, I think. So our last host would be the last number before your broadcast. Your broadcast is the last possible number you use. You take one away for your last host. There's loads more in that book, by the way. I'm doing a cram guide, so I can't cover too much. Coffee time. VLSM is short for variable length subnet masking. It chops your network into subnets. So if you've got a huge network with thousands of hosts available, it will let you chop it into manageable sections. So this bit here you could actually chop into a smaller part, and you could have a larger part here, however you want. So for example, you've got 200.100.0/24. If you change the mask to /25, you originally had one subnet with 254 hosts. If you go back to the subnetting column, you now have two subnets. One is 200.100.100.0, and because we've stolen one bit from the next octet, octet number 4, here 128, our second subnet is 128. So we've had our network and we've basically cut it into two slices using variable length subnet masking. All I can say about route summarization is you take whatever network numbers they give you, you count how many bits match, and then however many bits after that you would use for your they would be used for host, but you just count how many bits match. Now you can do this quite quickly, because don't bother with the first one, don't bother with the second one here, because all the numbers match. So you know all the way from bottom to top the first two octets are matching. You just need to worry about the third octet, and we can see we've got 8 bits match plus 8 bits match plus 1, 2, 3, 4, 5. All these numbers match that are underlined. So 8 plus 8 plus 5 gives you 21 matching bits. So you would advertise the lowest network number and the subnet mask with 21 bits, which is 248. Now, if you own this entire network, by the way, you could advertise, just read what the question says. You could possibly advertise that as long as it's nowhere else on your network. If you've got 172.16.10 somewhere else, you're going to have problems. So I mentioned this before. I've got IP subnetting from 0 to Guru. I only mention it because it's, I think, a couple of dollars on Kindle or paperbacks, cheap. And I've got 101 labs IP subnetting, which exactly as it says, it covers IPv6, version 4, route summarization, VLSM, a ton of stuff. So they're both on Amazon bestsellers. So if you want help with subnetting, check those out, please. Let's go into routing. This is the entire process from beginning. Where's number 1? Yeah, it comes in here. I'm not going to talk you through this. Step 2, 3, 4, 5, 6, 7, 8, 9. And before it's forwarded out the other side. This happens very quickly, obviously. The router, it does packet forwarding on a route lookup, maintains a routing table, never forwards broadcasts. The kind of routes you will be learning about are connected routes, so the directly connected interfaces, a static route which you configure, or dynamic routing via a routing protocol. Types of routing protocol, typical exam question. It will say, what's the definition of a routed protocol or a routing protocol? So just learn the two differences and learn the examples of which ones are there. You can have two main types of protocol, interior gateway and exterior gateway. BGP is added to the exam now. Learn the administrative distances. This is the believability of the route. According to the router. So learn all these: ERGRP summary, ERGB internal. They will try and catch you out, I guarantee. So which one is 170? And they will say, is it external, internal, summary? And in the pressure of the exam, you could forget. So make sure you learn. Unknown. And unknown route is dropped. Static routing, if you're the admin of the network and you've only got a handful of routes, then you can add it. You can also add it for a backup, which you can lab up, I'm sure, in your own time. You can add an administrative distance to the end. So here's an example: IP route to get to network 172.16.5 whatever with a subnet mask. Go to this address. This must be in your routing table. Obviously, it must be connected, or there must be a route to it somewhere, usually connected. You can, at the end, if you wish, add an administrative distance. So you could add 130 as administrative distance. And if there's a problem with your routing protocol, this route would kick in. Hopefully that will be covered in any book. If you don't know, if you go to a customer site and install a router and don't know their next hop, or it keeps changing, just specify an exit interface instead. For IPv6, here's an example of a static route going to a particular network with your CIDR and then your next hop. RIP is back in the exam, thankfully. It's a distance vector protocol. Classic exam question. It uses UDP, not an IP port, and it's 520. Uses for a metric the hop count. So no matter how fast your link is, it does not understand that this is a faster link. All it knows is how many hops. So to get to from here, it's 3 hops if it goes this way. It's 2 hops. So basically it's going to take this path here if it's using the hop count. So just be careful. You can load balance. V1 is classless. Class full. I'll fix this when I do the slides. The way I remember this is full. Class full means it's full of CRAP. So basically it's rubbish. RIP and IGRP. It's not in this syllabus, but it could be one of the things to tick as a class full protocol. Version 1 broadcast updates, version 2 multicast updates. Important thing to remember. Version 2 supports MD5 authentication for your security. Configuration is really easy. Router RIP. Put your network. You don't need subnet masks or slash addresses or anything like that. If you want version 2, you put version 2. It will automatically summarize. So if you're sending out 172.16.10.0 on the classful boundary, it will summarize it. So be careful. If you don't want that to happen, you turn it off. If you don't want it to advertise routes, then add the passive interface under config router mode. It will receive routes. It won't send. Show IP protocols is probably your go-to command for any routing issues, and it will tell you what your timers are for sending packets, when the next one's due, when it's invalid, your hold down, your flushed, your protocol. This is telling me it's sending version 2 and receiving version 2, so it's RIP version 2. Network summarization is not in effect in this particular version. Here is a debug IP RIP, and it's telling me it's sending a version 1 update. This is a broadcast, so this tells us it's version 1. And remember, look also here, it's not sending the mask. There's no subnet mask here. So this is telling us it's class full of CRAP rubbish. This is basically, it already tells us version 2, but if you couldn't see that, it's multicasting the update, and it's sending the subnet mask information, which allows us to use our subnet mask information, or CIDR. So important to see the difference. Inter-VLAN routing is covered in the syllabus. I think it's actually in the syllabus for both ICND1 and ICND2, so be careful if they try and catch you out. You've got a few options: a router with a VLAN trunk connecting to a switch. You can have a sub-interface for each VLAN that's required to be routing. So these are the steps. I've got a sample configuration here. So if I've got my switch here, I'm going to configure it as a trunk port, and then I will ask my router to do the routing protocols. I've only got one interface on this particular switch. You could have multiple interfaces, but it just makes it quite difficult because you're going to run out. You need one per VLAN. So what I'm going to do is configure sub-interfaces. So 0/0.10.20 and so on. So this is the configuration on my router. I need to set my encapsulation .1q, my IP address for the .10 and the .20. This will be my default gateway for VLAN 10 and VLAN 20. Probably easier if you do a lab for this part, to be honest. ACLs are packet filters, access control lists. They can look at source, destination IP, source and destination port, depending if it's standard or extended. These are your port ranges. You will be asked in the exam to tick what the possible numbers are for standard or extended. So make sure you learn. You probably only really need to learn these 4. You must apply them to an interface. I only say that because I've dealt with a lot of students who've been studying and forgot to actually apply it. If you use a named access list, it is case sensitive, so you need to make sure it's upper or lowercase. You can edit a named access list. I think you can change a numbered also now. We'll have to look into that. Some examples of access lists. So create my access group, and then so I'll apply it to this interface with this command. This permits TCP from this host to this host on a port equaling 80, so web traffic. Standard access lists filter on source only. So it will permit, and I've just put a host address here. Named access list, this time I've called it access list. I have to put IP access list, block web, and then the direction. And then it's permit TCP from this host to this host, and again it's port 80. Easiest way to work out wildcard mask, which you use for OSPF and ACLs mainly, is you take whatever the subnet mask is, and if you want to work out the wildcard mask, you've got to add something to it to get to 255. So 224 add 31 gets you 255. You've got 0, so you have to add 255. You have to add 0, sorry, and here the same. So I'm just doing my addition there, confused myself. So whatever you add here has to equal 255. So you add nothing, you add 31, and you add 255. NAT translates internal to external addresses. You'll also use it for security to mask your inside addresses, preserve addresses. Here's a sample config for static NAT. Most important in the exam, they will try and catch you out. You must say what is your inside interface, and you must say what is your outside interface. You must configure it on the actual interfaces, otherwise your NAT won't work. You could either have a question or a lab to configure, or you could have to go into a live router and use your show commands to work out what's going on. And for this particular one, it would be a show run, and you would see that these are missing. Dynamic NAT is basically a NAT pool, and you can see I've configured again my inside outside. I've given my NAT pool a name. I've configured a pool of addresses. This could actually just be one address, but you still have to have two parts. You can't just have one. This is going from number 1 to 10, and you can see I didn't add a mask. I typed the command prefix length, and I think, please do check, the other way you can do it is by adding the net mask, etc. But do check that. Then I'll go my source list 1, which is basically an access list, and I'll reference the pool name again, and then my access list is saying what is permitted through this pool. Port address translation is the same as dynamic NAT, but at the very end we have this important command here. So now we're doing our translations using port numbers. So it'll use the IP address, whatever, but it will add a port number to the end. NTP uses to synchronize time on our network. This is how you'll reference an NTP server. You'll just put the IP address. The show command is here. Show NTP status here will give you information about your NTP server configuration. IPv6 very quickly is 128-bit addresses. It's in 8 parts. Each is in 16 hex bits. So we can see 1, 2, 3, 4, 5, 6, 7, 8, and each of these is in 16 hexadecimal bits. It doesn't use broadcast. We've got multicast, anycast, and unicasts. If you're going to use it with IPv4, we'll be using tunneling or dual stack. Here are your options, which will be in the exam. You can tick the various methods available for working with an IPv4 network to transition to IPv6. You need to know how to compress, and these are your two main methods. This makes your address shorter but still legal. Double colon, only once. That's the rule. You can only use that once, and you replace your leading double zeros. I can use this double colon once in this address, and that's telling me everything in between here is zeros, and if I go over here you can actually confirm that. I haven't compressed the leading zeros yet. This is just the first example. So omit leading zeros is where you take anything that starts with a 0 and your addresses you can get rid of, and you'll get the 1, 2, 3 ABC. You cannot omit trailing zeros. No, do not do it. That is still here, so be careful if they try and catch you out in the exam. And it's worth saying that you use method 1 and 2 together, so you can use the double colon obviously once, and you can use omitting the leading zeros. That's how you would normally do it. EUI addressing, best to check your books and videos. This can be a bit tricky, but basically you flip your 7th bit in your MAC address, and this will make your IPv6 address unique, and it will use part of your MAC address. It takes a little bit of a while to get your head around this. I think I've got an example here. So if I use my show interface, fast Ethernet 0/0, it's got to beef this. It's got to beef up the MAC address here, so it is a legal IPv6 address. It's a 128-bit address. So you can see here 0A20. It's actually A20 because we've got rid of the leading zeros here, and then in the middle we've inserted this special character set called FFFE. And then something strange has happened here. We've flipped. If you write it out actually in hexadecimal or whatever, 0013. If you write this out in full hexadecimal, you will flip the 7th bit from a 0 to a 1 or a 1 to a 0, thus enabling the change. You can see here the 0013 has changed to the 213, and we've omitted the leading 0. It's hard to explain in a short Cram guide, so please read up on your study guide, or you can easily check it on Wikipedia also. These are your address types. You need to know all of these and how to recognize them. There's a special character set in hex for you to recognize. Unfortunately, you've got to know all of these. This one's been depreciated, so you probably don't need to worry too much. Your link local addresses are only used on your local link, so basically on a shared segment. So your router to router communication will use the address to communicate from here to here. It will not then forward this address over to the other side of the LAN. Multicast addresses are derived from this is one of the addresses I listed earlier, FF00 then 8. Anycast is one to nearest communication. Loopback addresses are used, and it's the equivalent of 127.0.0.1. The prefix for IPv6 is just : and then a 1. Unspecified addresses are unicast addresses not assigned to any interface. These indicate the absence of an IPv6 address. This is going to be used for duplicate address detection or to allocate an IPv6 address, and it will basically say I don't have an address, and then you will normally be allocated one. NDP is a plug and play feature of IPv6, operates in the link layer, and it's basically there to discover nodes on the link, which I'll show you in the next slide. So the way to think about it is the way ARP works on IPv6, because there's no ARP in IPv6, we use NDP. So the easiest way to look at it is the RA packets here. This is sent out by the router solicitation. So router advertisement is coming from the router solicitation packet is coming from the host on the network. Some important commands which you need to try whenever you do an IPv6 lab. Finally, syslog is an important thing, often forgotten about, but it seems to come up time and time again in the exam. It's basically a little server that will run. It can run on a router or a server, and it listens to messages and it will store them in a log. It uses UDP, bear in mind, so it's unreliable. Packets are unsequenced and under knowledge, so you wouldn't know if it isn't working. You can read the rest for yourself, I'm sure. What you do need to know, unfortunately, is all of these. So if you see a login level, you need to know it corresponds to emergencies. If somebody asks you what's login level 5, you need to know it meets notifications level, and then you also need to know the description. So pause the video, and unfortunately, got to learn all that stuff. Alright, so that's the end of the presentation. As I said at the start, please, if you go to howtonetwork.com, I'll let you know when new ones are out. Subscribe to the video also, and you can see the new editions as they're released. And I hope it helps. Good luck in your exam.